In this lab, you will use a mass on a pulley system to pull a car down a track. You will use a distance sensor to record the car's position as it progresses down the track, and then you will add mass to the car and repeat the process. When you look at your graphs to analyze the data, you will find that they are not linear. You must convert them to velocity time graphs. This can easily be accomplished in Data Studio. You should find that the velocity time graph is indeed linear and can further be analyzed. You can analyze this graph by looking at the slope. The slope of a line is defined by the change in the y value of the change in the x value. Since this is a velocity time graph, the slope of this graph is the change in velocity over time. And since acceleration is the change in velocity over time, the slope of the graph is the acceleration of the car. When you find the acceleration of the cars with different masses, you will be able to see that the car with the higher mass has a slower acceleration. This can be explained by Newton's second law, which states that the force on an object is equal to its mass times its acceleration. Therefore, the mass and acceleration are proportional to the force, and are inversely related to each other. The force is constant in all of the trials, so mass added to the car results in a slower acceleration. We will now derive an equation that can be used to mathematically calculate the acceleration of the car when you are given the car's mass and the mass of the hanging mass that is pulling the car down. You will start by finding the force acting on the car. From Newton's second law, you know that the force equals the mass times the acceleration. The car's force also equals the force and the tension of the string. You can then eliminate the force and set the two equations equal to each other. Now you must find all the forces acting on the mass. The force equals mass times the acceleration from Newton's second law. The mass has gravity pulling it down, but it also has the force of tension in the string pulling it back up. Therefore, the force will equal the force of gravity minus the force of tension. You then will combine these two equations by eliminating the force variable and setting them equal to each other. To finish the derivation, you must combine these two new equations. To do this, you must first solve them for a common variable to eliminate. You cannot eliminate the acceleration because it is needed in the final equation, so you must eliminate the force of tension in each of these equations. Solve these equations for the force and tension, eliminate force of tension, and then set them equal to each other. To finish deriving the equation, solve the resulting equation for acceleration. Now that you have an equation for acceleration, you can calculate the theoretical acceleration of your car for all three runs. You can then calculate a % error between your actual acceleration and your calculated acceleration.